Hello and welcome everyone to our new topic, which is trigonometry. To begin trigonometry, we're actually going to be going back a step and doing a quick recap on Pythagoras' theorem. The reason for this is we need Pythagoras' theorem in this topic, at least for some questions anyway. So let's just get straight into it. This is the start of our notes, so hopefully you've got your maths book ready. If not, pause the video now. Make sure you grab your maths book, pen and calculator. Once you have them, press play on the video and let's begin. Alright, so for our notes, so in your book, can you please put the heading trigonometry up the top, nice and big. This is going to be the topic we're going to be working on for at least the next 3 weeks. So that's our topic, and our first subheading is going to be Pythag recap. Alright, so our notes, so we're going to be copying this into our books as well, so pause the video if you need to. I'll just read it out for you. It's used to find the side length of right-angled triangles when other two sides are known. So I should probably put an S there, I guess. Alright, let's just get straight into some examples. Alright, so in year 8, you would have spent lots of time going through all the fine details of Pythagoras, where it comes from. You would have seen lots of different types of scenarios where you use it. For trigonometry, really all we need to be able to do is just find the length of what we call the hypotenuse and be able to find the length of a shorter side. They're the only two parts we really need from that Pythagoras topic, so that's all we're going to focus on here. Alright, so for this one here, we can see we've got a right-angled triangle. We know the length of two of the sides. One of the sides is missing. In this particular case, it's not just any side. This is what we call the hypotenuse, right? It's the longest side of a right-angled triangle. It gets a special name, the hypotenuse, and we will actually need that for trigonometry. Anyway, we're just trying to find the length of this missing side. When the missing side is the hypotenuse, ultimately, all we need to do is square root the first side squared plus the second side squared. Because there's a plus in the middle, the order in which you put the numbers does not matter, right? 2 plus 3 is exactly the same as 3 plus 2. So the order won't make a difference, but I just, out of habit, I just always put the larger number first. So it'll be the square root of 8 squared plus 6 squared. You then just type that in the calculator, exactly how it's written, and you end up getting the length. In this case, it would be 10 centimeters. That is it. Right, that's how you find the length of a hypotenuse using Pythagoras' theorem. Right, so you always use the square root, and it's always the first side squared plus the other side squared. Now, you might remember from year 8 that there might have been extra steps where you wrote out Pythagoras' theorem and then rearranged it, but ultimately, if you're just trying to find the length, this is all you need. Let's look at another example. This one here, oh, there's decimals, right? Some people will look at that and think, oh no, how are we going to do this? So much trickier. It's just done the same. We're trying to find the length of the missing side. And again, we can see from the right-angled triangle, it's actually the hypotenuse. It's the longest side. It's the hypotenuse, which always, funnily enough, happens to be directly opposite that right angle. All right, so if you're trying to find the length of the missing side and it's the hypotenuse that's missing, well, we just saw how to do it. Let's do it again. It'll be the square root of the first side squared plus the second side squared, right? Make sure you don't forget your squareds when you do that. And then you just type it in. You press equals on your calculator. We went to 1 decimal place here with this, so we'll probably stick to that same theme and we'll round our answer to 1 decimal place. It ended up being about 3.8. In this case, it was meters. That was to 1 decimal place. I've rounded there. You actually, once you type that into the calculator, and if you do actually type that in yourself, you'll see there's lots more decimals. Actually goes on right to the end of the screen, right? It's one of those irrational numbers. But yeah, just round it to 1 decimal place. This is enough accuracy for us. All right, so now we've seen it twice. You're trying to find the missing length. It's a hypotenuse. You set up the square root. Make sure you put a plus in the middle and make sure you square both of those numbers. That is how you find the length of a hypotenuse. That's all you need to do. Now, sometimes the missing side isn't the hypotenuse. It's one of what we would call in year 8 the shorter sides. We're actually going to learn in trigonometry in the next lesson, funnily enough, that these shorter sides actually have their own special names. But for the moment, they're the shorter sides. And the way you find the missing length is almost the same. There's just one subtle difference. So we're still in this Pythagoras' theorem, right? We're trying to find this missing side length. In this case, we actually have a name for it. It's k. So what is k going to be equal to? Well, we set it up the same way. Square root. The first side squared. The second side squared. Again, notice I'm using the larger number first. But in this case, when it was the hypotenuse we were finding, we had a plus here in the middle, right? Finding the hypotenuse, there was a plus there in the middle. Well, when you're finding the shorter side, instead of a plus, we put a minus in. Ultimately, that's the only difference. If the missing side happens to be shorter, instead of a plus, put a minus in. Everything else is done the same. You press equals, your calculator will give you the correct answer. And that is it. Pythagoras' theorem, that is all you need to know for Pythagoras' theorem in this trigonometry topic. So what I'm going to get you to do is, before you close down the video, make sure you get these 3 examples into your books. Okay, so I'll just tidy it up a little bit. So that includes diagram and working out, right? Just so you've got it all there. There will be some times throughout this topic where you will need to use your Pythagoras' theorem, and just having a couple examples written in your book will avoid you having to go back and find this video and then re-watch it. All right, once you have these examples in your book, I'm going to sign off here and I'll see you for the next one. All right, bye.